Hello. It has been 8 years since I machined this nice relief model of the island of La Palma, one of the Canary Islands. It was after a hiking trip that I made on this island that it allowed me to exactly see where I walked. For instance, here an image where we are walking down this ridge into the mist, and that we see the top of the old volcano there floating above the clouds. Next is I'm standing on this top looking over the clouds. It was a great trip, but that's not what this video is about. It's about it's about CNC machining and then laser engraving a relief model, because this model was machined with an old DeskProto version 6, and the current DeskProto version 8 also supports laser engraving, and not only on flat surfaces, also on 3D models like this relief. So my idea was, why not create a file with all major roads and city names, village names, etc., and engrave that as extra information on this relief. That should be possible using DeskProto 8, and I want to show you exactly all the steps that I followed to create this model. So let me first start creating the CNC toolpath. I will do that a bit quickly, as that subject has been covered in other videos before, and after that I will add the vector lasering. Okay, first start DeskProto. Obviously we need DeskProto version 8 in order to do laser engraving. In this dealer edition, I need to select a license. When you have bought a license, this screen won't pop up. And I'll start with a new geometry project. And I want to load the STL file, same STL file that we used in 2017. Here it is, lapalma.stl. I open it and I select the top view. And the first thing that we can observe is that it's rotated a bit very strange around the Z-axis. So I want to correct that. So the first thing I want to do is transform and make a rotation around the Z-axis, and I found out that it's 1.39 degrees. Apply, and now it's nicely aligned with the X and Y axis. Next thing is the dimensions. It's about 100 millimeters in the Y. My block is larger. It's about a bit over 200, so I'll just use scale factor, a factor 2. And for the resulting relief, I want to cheat a bit and make the scale factors non-uniform and scale the Z a bit more than X and Y. So the mountains will be a bit higher than in the original, in reality. Apply that, and then I want to enter the dimensions of my material block. I say set custom size, and my block it's 125 times, what was it, 220 times 25 millimeters. And when I say set custom size, the STL file will be positioned in the center of the block for all axes. So I say apply. It falls partly outside the material block. I can see that, but that's no problem. I can say OK, and you can see that here on the X it's a bit larger, and on the Y my block is a bit larger. Let me check the front view, and indeed it falls completely within the block in Z, so all mountains are included. That are the part parameters, so this is what we want to machine. And then I need to enter settings for two operations. First operations is roughing. Roughing, yes. And the roughing settings are go down in layers of 8 millimeters, seems okay for this wood. The skin of 0.5 millimeter to be removed while finishing, and enter the material at a ramping angle. Okay, the cutter, it's okay, a 6mm bull nose. I want to use that for roughing. And the distance between the toolpath may be a bit larger for roughing, but the step size, I want to take that small to make sure that all details are present in the resulting part. Maybe a bit faster, 600, 9000 is okay. The strategy parallel is okay. I did roughing settings. My area, the area should be a bit smaller because on the front and the back of the block I want to use clamps, and so I do not want the cutter to come there. So I set it to custom, and at the front I reserve 15mm for the clamps, and for the back, so the maximum Y, I also make 15mm smaller. Okay, here we are. You can see here in the top view again, this is the part of the block, the area that is not machined. So here I can position my clamps. Okay, let me calculate toolpath. Did I forget something? No, I forgot roughing. I need to go make more settings and say no extra for borders, because normally the cutter will sink to ambient level outside of the geometry, which is not needed here. And the rest of the settings is okay. Yes, so I can calculate toolpath. Here we are. It goes down in two roughing layers, -8, -16, and well, that will be, let me check the simulation, calculate, result will look like this. Well, that is okay, so I can export these toolpaths. Yes, that's no problem. In, I say it roughing, again, same error, roughing. Yes, here is roughing.nc, and I can go to the milling machine with that file and show the roughing process. So for the roughing operation, now the finishing, and I want to show you the cutter that I will be using. It's made by CMT, and it's a tapered cutter, so from thick in a conical shape to thin with a very small tip radius, 0.8mm. And so with this cutter I can create very fine details, and at the same time it's a very stable cutter because of this conic shape, much more stable than a normal straight 1mm diameter cutter would be. So this is the cutter that I want to use for the finishing operation, and I will create it now. And here we are again on the computer, back to DeskProto, where I now want to add a finishing operation, a geometry operation, call it finish. Yes, and the settings, first select a different cutter, which is the tapered cutter that I just showed you. Tapered, here we are. The precision must be much higher, so I want to make 10 toolpaths per millimeter, and for the step size also 1/10 of a millimeter. Feed rate may be a bit higher, as not so much material needs to be removed, only the roughing skin needs to be removed. Strategy is okay, no roughing settings. The area, also for this operation I needed a bit to make it a bit smaller than the material block to keep this part of the block free of my clamps. So here also Y from 15 to 205 millimeters. Again, no borders. That's it. So I can calculate the finishing toolpath. Yes, here we are. It will be a long job. And what, oh yeah, the simulation, let me show that. I now add the finishing to the simulation, and much more detail is present because this cutter has a very small tip. It's smaller than a millimeter, the tip, so it will be a very nice result. Hide again the simulation, make roughing invisible, and now save the toolpath file for finishing for only this operation. Finishing, yes, and that is a bit longer file, obviously, as you can see here in the toolpath. Here's the finishing NC file, and with that NC file we can again go to the milling machine. And now we're starting with the really interesting step in this tutorial video, the laser engraving. Obviously I needed something to engrave, I needed a graphic design, so I started with Google Maps and I took a screenshot of the island of La Palma to start with. Well, a screenshot obviously is bitmap information, and for laser engraving in DeskProto V8 I need vector data, curves. So what did I do to make this conversion? First, in some paint-like program, I removed the color of the sea, made it white, and then I removed all other colored areas so that only the gray and black pixels indicating the roads and the characters of the names remained. And I took that bitmap file into Inkscape, and Inkscape has a function called bitmap tracing, trace bitmap, where it converts this bitmap into curves. I won't go into that in much detail as this is a DeskProto tutorial, but after bitmap tracing in Inkscape, I could save the file as an SVG file and then load that SVG file as vector data in this DeskProto project. So I'll show you how I continued. Back at the PC, and here is DeskProto, the project as we just left it after the roughing operation, the finishing operation. And now the next step will be adding operations for the laser engraving. So the first step is to load a vector file, and this file, La Palma Roads, is the file that contains all the roads and the names of the villages. Here it is, and it looks a bit weird. Yes, the top view. The reason is that we have set the block to a certain size, and it will center the block in all CAD data, and obviously that doesn't work because the scaling of the vector data is not correct. So I'll first fix that. Go to the part parameters, geometry setting. Here are the vector settings. The scaling is for the vector only, and well, this is a process that you will need to do by trial and error. Just make it smaller and then pan it a bit, just as long, just until your vector curves nicely match with the STL geometry. There has to be a smarter way to do that when you get both your 3D geometry and your vector data from the same source. However, I haven't found out how that works, and for this one project it was okay to make an iteration until it just matches fine. So the resulting scaling factor that I needed was 0.33448. Apply. Here we are. Yes, and then I also need a small panning. As you can see here, it doesn't match. 7 millimeters for X, and what was it, 0.5 for Y, 0.5 for Y, apply. And as you now can see when we zoom in, here this is along the edge of the island. It's fine here as well. Just check both sides obviously. So I'm quite happy with this result. It's nicely aligned. Okay, that's the first vector file. The second vector file is the name La Palma. I want that also laser engraved as an indication what this is about. Open. This is okay, and here we are, La Palma, and both I want to use both files for laser engraving. For the roads I want to use profiling, and for the name I want to use pocketing to engrave all space inside these closed contours. So the next step is that I need to make a vector operation, add a vector operation. Here we are. I call it laser engraving, laser engraving. Here we are, and obviously I need to select a laser cutter. The 0.1 millimeter curve is okay for my machine. Feed rate, S value are all okay. I'll leave it as it is. And the most important one for the Z settings is that I need to project my vector curves on the 3D part. Let me show you how this works. Just say OK for now. No curves have been selected, that's OK. As you see now, the vector data it's a flat vector image, and obviously I want the laser cutter to follow the surface of the STL file, so to add 3D information. So that's why again, for the Z settings, I need to select project the vector curves on the 3D part geometry. It will be a vertical projection, so that will end up fine. And the calculation precision needs to be better than that. 0.1 millimeter precision. Free movement need not go up. For all positioning movements is that no need for the laser engraver to travel to 5 millimeters above the block for positioning. So I'll make that 1 millimeter and allow it to always stay low. Now it will calculate for each positioning path. It will calculate the highest point of the geometry below that path, and it will pass with 1 millimeter extra. It will pass over that highest point. Okay, then for profiling I want to use the roads profiling, and I can do that by selecting a layer. The nice thing is that the roads the SVG file for the roads were made in Inkscape, and there the default layer name is layer.01, so I can simply select that layer to have all roads. I want them engraved on curve, so I say okay, no, I want to also do the other file, and that is pocketing for the laser name. Then I can select the other layer default. This file comes from a different CAD package from Rhino, and there the default layer name is default, so that is nice. Okay, that are all settings. Well, it's very easy. I can say calculate toolpath, yes only, just cancel, just switch that off. And now I can say yes only the visual operation. That will take some time, all calculations, and you can now see here the 2D, the roads, 2D curves have been projected on the 3D geometry, and here for La Palma the toolpath will pocket all area inside the text. So that seems to be exactly what we needed. So I now can save this file with all the vector engraving for the third NC file. Yes, save NC file, only the visible operations, and it called that one laser. Yes, save. Yes, it takes some time. Here it is, the third file, and with that file I can now go again to the machine in order to, where I need to switch my spindle, my milling spindle for the laser unit, and then I can continue. One more detail. In the project that I just showed you, I loaded two vector data files, and then I transformed the vector data, so scale and pan, to match the geometry. I did that using the part parameters, and the part parameters are valid for all vector curves. So what if different transformation, different scaling is needed for each file? Well, then I can also apply the scaling, panning, etc. per vector file. I will quickly show you how to do that. It's pretty simple once you know how. Let me make a top view and shift that a bit to have some room for the other dialog, because you can see all CAD files that we loaded in the project parameters. We loaded two vector data files, in for all roads and names, and one just for the name La Palma, and one geometry file, the SCL file La Palma. And for each of these CAD data files you can open a transform dialog in which you can do scaling, rotation, etc, etc. So say I want to make this word La Palma a bit larger. Then I open the La Palma file, go to transform, say 1.25 scaling, preview. You can see it has become larger. I have to shift it a bit to the left, say minus 15 millimeters. Preview again, here we are, and when I now say OK, and here OK as well, the toolpath will be recalculated, and here we are, a bit larger word La Palma. Not yet optimal, but you see how it works. And well, after that small detour, now we can really go to the CNC milling machine to start the laser engraving. And here I have the resulting models, the old model and the new model. As you can see, a big difference. I'm very happy with the result of all the engraved lines on top. Evaluating the result, I have two details that could be improved. First, you see the road here, which is over a steep ridge. The road goes up, seems to go up and go down in a straight line, which is not possible for a road. And what happened there, at that location, a tunnel is present. Well, in Google Maps, still the road is drawn for the tunnel, but next time I need to edit the vector data to remove the line at that point because it's not visible, it's a tunnel. Second detail is that the laser engraving took a very long time, and that was because you can see it when you zoom in or not. For each road and each character, the bitmap tracing resulted in a large number of lines at that location, while only a few would have been sufficient. So next time I'll need to dive into the trace bitmap settings to improve that. But nevertheless, it's a great result. I have one more detail that I want to share. When you do a project like this, you need to take care that the laser head does not collide with your model, which can happen with high and steep surfaces. In DeskProto version 8, version 8.1, we are already working on that. We will include a collision check of the model with the laser ahead, making DeskProto correct the toolpath if collision would be present. Also new in version 8.1 will be that DeskProto also will support the engraving of bitmap files, making this process a bit easier. Well, for now, thanks for watching. I hope that it will be inspiration for you to create similar models using your DeskProto CAM software. Thanks for watching.